This is the second example of today's notes. We ended class looking at one example, and this is the second one. Number 2 is f of x equals 3x squared divided by x squared minus 4. Remember, we're going to use the directions as kind of a checklist. The directions had said to determine the asymptotes, x-intercepts, graph, and domain and range. So first, let's start with the asymptotes. I will consider my vertical asymptotes first. Vertical asymptotes come from the denominator, so I set x squared minus 4 equal to 0. And then I ask myself, how would I solve this? So I could either solve by square roots, or I could factor. I choose to factor, difference of squares. And I get two vertical asymptotes from this. X equals positive 2, and x equals negative 2. For my horizontal asymptote singular, remember there's only ever one of them, we need to look at m and n. M is the degree of the numerator, which is 2. N is the degree of the denominator, which is 2. Here, m equals n. So we need to look at the coefficients, divide the coefficients. So a sub m divided by a sub n. In this case, that's 3, and then there's an invisible 1 right here. So my asymptote will come from 3 divided by 1, which is y equals 3. So I have my vertical and horizontal asymptotes. Next, we will look at x-intercepts. X-intercepts come from the real zeros of the numerator. So I look at 3x squared. I set that equal to 0. Dividing by 3, I get x squared equals 0. And if you take the square root, the square root of 0 is 0. So I have one x-intercept at 0. I'm going to be clear in labeling this as an x-intercept, because notice x equals 2 and x equals negative 2, those are going to be vertical dotted lines on our graph. We don't want to confuse this as being an asymptote just because it says x equals. So here, this is an x-intercept. Let's get a sketch of a graph just with the information we have so far. I'm going to draw a 10 by 10. Okay, let's go back up and see where our asymptotes are. So we have two vertical asymptotes at 2 and negative 2. So let me draw in my vertical asymptotes. Here's one at negative 2. And then positive 2. I'm going to highlight them so they stand out. Okay, So we have our vertical asymptotes at 2 and -2. And then I look, we had a single horizontal asymptote. Remember, there will always only be one at y equals 3. So I come back over here and go to y equals 3. We're going to draw a horizontal dashed line. If you would like to use a different color for the horizontal asymptote, that's fine. Or use the same color. Highlighting them really helps them stand out on my graph. Before we go any further, let's actually get this into our graphing calculator. Make sure you use parentheses around the numerator and parentheses around the denominator. So press pause, go get your graphing calculator, and let's get a little side view. Quick little sketch of what it looks like in the graphing calculator. If you need to press pause to go get that, please do so. If you're listening further, I'm assuming that you got your graphing calculator from your book bag or your desk. You have successfully plugged in 3x squared. Remember, you put this in parentheses and then divide by that in parentheses. And your screen on your graphing calculator should be showing you something like this. So there are actually 3 parts to this graph. The reason why this sketch will help us is we know what x values we are going to get. So I can see, clearly the graphing calculator doesn't put in dotted lines. But here's mine's not super accurate, but this shouldn't go so far over. But here's that -2. Here's the +2. And then here's the effect of 3. So that means that I need 2 points to the left to get 2 ordered pairs for this piece. I'm going to need 2 points in the middle and then 2 points to the right. So remember, this is -2 and this was 2. So if I'm looking for 2 points to the left, maybe I choose f of -3 and f of, I'm not sure, let's say -7. Notice I didn't really leave a lot of space to do the math because as of now, we will start using the tables in our graphing calculator to get our points. So go to the table. F of -3 from my table is 5.4 and f of -7 is 3.3. So that gets me -3, 5.4. This gets me -7, 3.3. So let's go graph those 2 points. -3, 3, 4, 5.4. And then -7, 2, 3, 4, 5, 6, 7. Here's 3 and a little bit. And I have successfully, sketched the graph for that piece. Then when I look at my little sketch here, This is going to bother me. Remember, the little green dots, your calculator's not showing you, but based on the asymptotes we graphed, we know they're there. So I need points to the left and right. But before I do that, let's make sure we find this maximum. So go ahead and go to second calc, or go to trace, get that calc option, just like we did in class, and hit 4. You want your left bound, and then scroll to the right, get your right bound, yes to guess it. Now I get negative 1.342 e to the negative 6. That's the calculator trying to tell you 0. And then same thing with y. I got y equals negative 1.35 e to the negative 12. The reason I know that is because there is a piece of information we haven't graphed yet. We know I have an x-intercept at 0, 0. So when I look, that's at 0. So I need, if I'm looking for 2 points in this section, I'll go 2 points to the left of 0 and 2 points to the right. Or excuse me, 1 and 1. Let's just do 1 and 1. So I'm going to label this as middle. So to the left of 0 would be f of negative 1. To the right would be 1. And then again, let's go to your table. F of negative 1 is negative 1. So that's negative 1 comma negative 1. And then f of 1 is also negative 1. So that's 1 comma negative 1. Graphing those points, negative 1, negative 1, and then 1, negative 1. And then finally to the right, I'm going to go with f of 3. And f of 7. Pull those values from your graphing calculator again. So I go to my table. F of 3 is positive 5.4. And then f of 7 is 3.2667, which we will round to 3.3 for graphing sake. So this is 3 comma 5.4. This is 7 comma 3.3. Let's graph those 2 points. So 1, 2, 3, up 3, 4, 5.4. I don't know where I just pulled that order pair from, I'm sorry. Starting at 0, 0, right 3, up 5.4 would be right about there. And then 7, so 2, 3, 4, 5, 6, 7, up 3.3, a little bit more than 3. So we successfully have finished our graph, and now we just need to discuss domain and range. So wrapping up the video for domain and range, I had just pressed pause real quick, and I'm coming back to wrap up this one little piece. I'm going to have the graph on the screen so you can see it at the same time. So for the domain, I'm looking left to right. The vertical asymptotes are what needs to be excluded. So negative infinity to negative 2, union, negative 2 to 2. That's part of the graph, right? This whole piece. Notice all parentheses, union, 2 to infinity. If you were going to use set notation, this would be all real numbers, x not equal to negative 2 or 2. For the range, we're looking at only the horizontal asymptote as needing to be excluded, but it's not just that, because if I look, the maximum here was at 0, 0. So this is where, in the notes, we said there's a gap. So it's not just about the horizontal asymptote, because this whole section, if you look, there's no graph. So what we're going to make sure we pay attention to is that maximum. For the range, I have a graph from negative infinity to 0. That exists, and it's going to be a bracket at 0 because I have an ordered pair there. Then that's going to be unioned with, this is at 3 to infinity for the y value. So this example shows us what happens when we have a gap in the graph and how that affects the range. That was part of today's notes. So that wraps up the second graphing example. It'll be on Google Classroom. Any questions on domain and range? Really just analyze where does the graph exist and where does it not exist. And we will talk first thing tomorrow about any questions you have for the graphing. Remember to use your graphing calculator as a what will this graph look like when I'm done with it. Getting a picture can really help you to see what you have. All right? Any questions, send me a reminder.